The GPU way works differently. So only one head checks, so it's called the control unit. So you only need kind of one head, and the head is going to tell everyone to chop onions, and all 32 chefs is going to chop onions, and the head is going to execute and other instructions for say add to the pan, and these sorts of way to make 32 meals have a very clear advantage. So only need one recipe book and one set of instructions, and only one management is needed. However, the trade-off is that it can only make so the 32 dishes can only make the same dish. So going back to programming, CPU can run different programs like completely. However, GPU cannot. GPU can only execute one set of program but across 30 across a multi-set of data. So for 3 threads, GPU can actually run the program A, program B, and program C run with different codes, and it can predict its own what to put into the cache, and also it can have 32 programs run by themselves. However, for GPU, it will run all 32 threads running the same program, like just adding. So it can only add for 32 times. But the good side is it only needs one control unit. Okay, so these are the trade-off for GPUs. It is actually trading the control unit with the ALU cores. So you have so many ALU cores that you can run only a few. You can only execute like say one instructions at a time. So GPU is giving up the complexity of control to more ALUs. However, this actually makes it very suitable for AI, because AI is simply millions of simple and repetitive operations that they do not need complex branching and speculation, but it needs a massive parallel in mathematics. However, there are certain code that you cannot run with a GPU, say if-else code. So remember, all 32 threads must execute the same instructions. If the code contains a if statement, it cannot. It will be so many processing time will be wasted, because half of them cannot execute. So the catch is for GPU, one lockstep means one instruction at one time. Therefore, if you are writing the if statement, so many processing time will be wasted. So the GPU had no choice but to sterilize it. So only certain amount of thread is active, and other threads will be not inactive, or will be inactive. So it will waste another cycle to execute the other half. So to summarize, only average efficiency is only 50% for one branching. So if your code have something like if, and you will waste about half of the computation power. So when you are writing code, please avoid branch diverge. Is the takeaway in here. So codes like adding is good efficiency with 100% no branching. Use branchless mathematics instead of using an if-else. So when you do vibe coding and say you are telling the AI to write the code for you in this course, please be careful and try to convert the if statement into a mathematic operation instead of the if. Okay, so when you look closely in this code, it says if the value is smaller than 0, it will kind of take the add a negative, which is flipping the sign and make it a positive value. If it is not if it is not 0, it will keep the result. So a good way to write this is to use built-in functions or use a custom logic. So a custom logic looks something like this. Value, if it is smaller than 0, it will say is negative. And when it's negative, it will multiply by the negative, so it will remove the negative. And if it is not a negative, it will keep the remaining value. Okay, so I've mentioned this before, how CPU handles the if situation. It will try to predict it will try to run all the code instead of waiting for the variable to come along to make it kind of run faster. So there are different ways for CPU to predict what to run. These are the algorithms they use. Some use pattern history table. Some use kind of a neural network-based predictor, and so on. So that's how CPU handles if else. But of course, GPU cannot do this because it relies on your input for it to run fast. Okay, so to summarize, we have two philosophies and different trade-off. For the control unit, the GPU have more silicon on the control unit, and therefore it can hold more complex operations. And the GPU do not need that many control units. However, the GPU will have much more algorithmic logic unit, which is suitable for AI computation. So when you are writing the code, if the code is actually complex, the CPU actually have an advantage. However, if your code does not involve a branching, GPU actually can run much faster. So, because AI is just keep doing simple maths like input weights and bias, therefore GPU have a huge advantage over this. So, take for example, a small model like a BERT-based model contains around 110 billion parameters, and each training steps involve 5 billion multiply and add operations. And the CPU will take hours to run, and GPU only takes minutes to run. So you have learned that GPU works have a major advantage in AI due to the simple mathematical structure of the current neural network models. So I will take the questions and I will give you a break in here. And after the break, we will be logging into the server that you will be using in this course.